morning, my dear students. In my previous video session, we were discussing how to determine the electric currents in a complicated electric circuits with the help of Kirchhoff's current law as well as Kirchhoff's voltage law. Some of the complicated circuits we discussed. Okay, and in today's class we shall discuss some more important complicated electrical circuits so that we will understand how to determine the electric current, okay, by using KVL and KCL. Okay, look at the circuit diagram carefully. 2 ohm and 3 ohm resistors are given. 3 volt and 1.5 volt sources of EMF are given. Okay. Okay. First we shall name the circuit A, B, C and D. Okay. Now ABCD is a closed loop. Okay. Look at the diagram. In this diagram, no current is given. Okay. So we shall name the currents also. Let us take it as, since it is positive terminal, let us say it is I1 current. Okay. And this is positive terminal. Say it is I2 current. Okay. Since there are no junctions, same amount of current has to flow through the circuit. Okay, because see here, no junction is given. Okay, since I1 and I2 we can take it as constant also, because 2 ohm resistor and 3 ohm resistor both are connected in series. In series combination, current always remains constant. Okay, anyway, we shall begin our solution. Okay, we shall apply KVL to the loop. Applying KVL to loop. Which loop? A, B, C, D and A. A, B, C, D, A. Okay. We shall start from A and we shall terminate at A only. Then and then only loop is going to complete. Okay. See here, we shall begin from this point A. Okay. Current is along this direction. Okay. We are moving also in the same direction. Therefore, 2 ohm and I1 current. It is 2I1. Okay. And here, positive terminal appears first. Therefore, it is positive 1.5. And C to D. Okay. See here. C to D, you are traveling this way, clockwise. Okay. And the current is also flowing in the same direction. Therefore, 3 ohm and current is I2. This is 3I2. You reach D, and from D to A while traveling, first negative terminal of the EMF first comes. Therefore, it is minus 3 is equal to 0. Okay. So it is 2I1 plus 3I2 is equal to 1.5. Let us call it as equation 1. But as I have already told you, this 2 ohm resistor and 3 ohm resistors are connected in series. In series combination, always current is constant. See here. This is one resistor, this is another resistor, this is third resistor. Okay, these 3 resistors are connected across a source. Okay. See here. If I current is flowing through resistor 1, same amount of current has to flow through resistor 2 and same amount of current has to flow through resistor R3. Okay, because R1, R2 and R3 are connected in series. Okay, I current is flowing through R1, I current is flowing through R2 and I current is flowing through R3 also. Because to flow, there is no other way for this current. Okay, there is no other way. Current has to flow only this way only. Okay, therefore the current through R1, R2 and R3 is going to be I only. Okay, I will write here, since 2 ohm and 3 ohm are in series, currents will be same through both resistors. As you can observe the circuit diagram also, in circuit diagram there is no junction at all. Okay, if junction comes, then and then only current may change. Otherwise, current cannot change. Between the junction, the current is going to be same. Okay, therefore, I1 is equal to I2 is equal to I. This way we can treat. So let us call it as 2. Putting 2 in 1. Therefore, it is 2. In place of I1, I can write it as I plus 3I is equal to 1.5. So 2I, 3I, it is 5I is equal to 1.5, and I is equal to, it is 0.3 ampere. Therefore, in this case, I1 is equal to 0.3 ampere and I2 is equal to 0.3 ampere. Okay, this is our second numerical. Look at the circuit diagram carefully once again. 1 ohm, 4 ohm, 3 ohm, 2 ohm, 5 ohm, and EMF is connected. We don't know the value of EMF. Okay, and the question is, obtain the resistance between the terminals A and B of the given network. This is A point and this is B point. We are supposed to find out, okay, resistance, okay, between the terminals A and B. Okay, first what we are supposed to do is, we shall name the current. Let us say I current is flowing. Okay, once the current I enters at this point, okay, the current will differ. I mean, some amount of current will flow this way and some amount of current will flow by this way. Okay, say the current flowing by this way is I1, and certainly the current is going to be I minus I1 this side. I minus I1 is going this way and I1 is going this way. Okay, let us name this point or junction as M and this point as N. Okay, say this point is, this is also junction, it is called as C, and let us call it as D. Okay, where M, C, N, D, these are junction points. Okay, and I1 current is flowing from M in this direction. Till this point the current is going to be I1. This is I1. Okay, and the moment current I1 comes here at this junction, some amount of current will go by this way and some amount of current will go by this way. Okay, and the amount of current going by this way, let us call it as I2. I2 is going this way. Okay, and certainly it is going to be I1 minus I2. From C point, I2 current is going by this way and I1 minus I2 is going this way. Okay, and see here, I minus I1 is also entering D and I1 minus I2 is also entering D. Okay, therefore the current that flows in this direction from D is going to be I minus I1 plus I1 minus I2, where I1 minus I1 plus I1 cancels and the amount of current remaining is I minus I2. I minus I2. And already in this direction, how much current is flowing? It is I2. And see here, I minus I2 will also reach N, I2 will also reach N. Okay, and the total amount of current that flows from N to B is going to be I minus I2 plus I2, and I2 cancels, the remaining amount of current is going to be I. Okay, see here, from A how much current is entering? I current is entering, and from N how much current is leaving? I current is leaving. Okay, current entering the junction must be equal to current leaving the junction. Understand? So our naming is correct. Now we shall apply KVL. Okay, applying KVL. I have already told you these I1, I2 and I, these are unknown currents. We are supposed to find out the values of these unknown quantities. Okay, and we are supposed to keep these unknown quantities as less as possible, because the circuit is going to be, I mean the process is going to be complicated if more number of unknown quantities are there. Okay, so applying KVL to the loop, see here, M, C, D, M, it is a loop. Okay, this way we shall apply KVL. Applying KVL to loop M, C, D and M. Okay, see, we shall begin from this point. Okay, see, I1 current is flowing through 1 ohm resistor and our direction is also same, the current direction is also same. Let us take it as 1 I1 or simply I1. Okay, we reached C to D we are supposed to travel, and while traveling, see here, current direction is also same and our moment is also same, therefore positive 3 multiplied with current, so it is plus 3 I1 minus I2. So we reached D to M we are supposed to travel, because D is a junction point, M is a junction point, and see here, current is traveling this way but we are traveling this way, therefore it is negative, so it is 2 I minus I1 is equal to 0. So it is I1 plus 3I1 minus 3I2 minus 2I minus into minus plus 2I1 is equal to 0. So I1, 3I1, 4I1, 2I1, 6I1. 6I1 minus 3I2 minus 2I is there. So it is going to be plus 2I on that side. Okay. Or let us call it as equation 1. Okay. Next. Applying KVL to loop, 3 unknown quantities are there, I, I1 and I2. Even E is also unknown. Okay. So applying KVL to loop, this loop we shall take C, N, D, C. C, N, D, C. So we shall start from this point. See here, this way we are traveling clockwise, and 4 multiplied with I2. 4 I2. And I2 current is flowing this way. Okay. And here 5 I minus I2. Current is opposite to our moment, therefore it is negative. So minus 5 I minus I2, and we reach D. D to C we are supposed to travel. While traveling, see, current direction is this way and our direction is like this, therefore it is negative. So minus 3 I1 minus I2 is equal to 0. According to KVL, between the loops, the sum of algebraic sum of potential differences and EMF must be equal to 0. Okay. See here, 4I2 minus 5I minus into minus plus 5I2 minus 3I1 minus into minus plus 3I2 is equal to 0. I2 is there, I2 is there, and I2 is there. So 4I2, 5I2, 9I2 plus 3I2. It is 12I2. Minus 3I1 is equal to 5I. So this is our second equation. Okay. So this is our second equation. So look at the equation 2 and 1 carefully. Okay. So we shall rewrite this equation as this way also. 3I1 minus 12I2 is equal to minus 5I. This way also we can write. Let us say this as equation 2. Okay. See here. 6I1 is there. Okay. And 3I2 is there. For this we can multiply 4. Okay. If we multiply 4, this 3I2 is going to be 12I2, and here also it is 12I2. Okay. So we can subtract these two. Okay. If we subtract means 12I2 and 12I2, it is going to be cancelled. Okay. I will write here. Equation 1 is multiplied with 4 and it is subtracted with equation 2. Okay. So first 6 4s are 24 I1 minus 3 4s are 12 I2 is equal to 4 2s are 8 I. Okay. So we are supposed to subtract actually, therefore I will multiply minus to this equation. So it is minus 3 I1 minus into minus plus 12 I2 is equal to minus into minus plus 5 I. So 24 and it is going to be 21 I1. 12 I2, 12 I2 it is cancels, and 8 plus 5 it is 13. 13 I. Okay. Therefore I1 is equal to 13 divided by 21 I. So now we know I1 value, and we shall go for I2. Putting I1 in equation 1 is easy, therefore we shall take it as 1. So 6 into I1 value is how much? It is 13 divided by 21 I. Okay. And minus 3 I2 is equal to 2 I. So it is 8, 6 ones are 6. So it is 78 divided by 21 I. Minus 3 I2 is equal to 2 I, or 3 I2 is equal to 78 by 21 minus 2 I. Okay. See here, 78 I minus 21 2s are 42 I divided by 21. So 78 minus 42, it is going to be 8, 6 and it is 3. 36 I divided by 21. Okay. So 3 7s are 3 12s are. So it is 12 I divided by, actually 3 I2 was here, and I2 is equal to, so 7 3s are 21. So 3 4s are 3 7s are. Therefore I2 is equal to 4 by 7 I. Now we know the value of I2 as well as I1. Okay. So we shall use those equations. Before that I will write equation 1 and 2 here. So 3 I1 minus 12 I2 is equal to minus 5 I. This was our second equation, and I1 value is how much? 13 by 21 I, and I2 value is 4 by 7 I. Okay, I will erase this. See here, since E is also unknown, we shall consider one more loop. Applying, as I have already told you, if number of unknown quantities are 3, you are supposed to use 3 equations. Therefore we need one more equation. Applying KVL to loop, we shall use KVL to that loop in which this E is also included. Okay, and that loop is going to be, see here, A M D N B A. Okay, this way. See here, this point is A, this point is M, and this point is D, this is N, this is B. Okay, A, M, D, N, B, A. This is going to be a loop. Okay, I will write here A, M, D, N, B, A. Okay, so let us begin from this point. See here, I1 current, I minus I1 is flowing, therefore 2 multiplied with I minus I1. 2 multiplied with I minus I1. Okay, and we reached here. Once again, 5 multiplied with 5 minus I2. 5 multiplied with I minus I2. Okay, since the direction of current and your moment both are same clockwise, therefore I have considered both as positive. See, this is going to be positive. and this way. Once again, negative terminal of the EMF appears U, therefore it is minus E is equal to 0. So 2I minus I1 plus 5I minus I2 is equal to E. Okay. So 2I, we know I1 is going to be 13 by 21 I plus 5I minus I2 value is 4 by 7 I is equal to E. So it is 21 minus 13 divided by 21I plus 7 minus 4 divided by 7I is equal to E. So 21 minus 13 is 8. So 8 2s are 16. So 16 by 21I plus 7 minus 4 is 3. 3 5s are 15 divided by 7I is equal to E. So once again I is common. 16 by 21 plus 15 by 7 is equal to E. Okay. So I 21 is LCM. So it is 16 plus 45 is equal to E. So 45 plus 6 is 16. 45 61 divided by 21 is equal to E. Or E is equal to, or I is equal to 21 divided by 61 E. So now we know the value of I. Okay. And see, in question we are supposed to find out the resistance between this A point and B point. Okay. Resistance between point A and B. Okay. But before that, the potential difference is given by V is equal to IR. Okay. But in this circuit is connected with E. Okay. Therefore we shall take it as E is equal to IR. So E is equal to I value, it is 21 divided by 61 E into R. E is cancelled on both the side and R is equal to 61 divided by 21 ohm, or it is approximately 2.9 ohm. So the resistance between the point A and B is going to be 2.9 ohm. Okay, this is our next numerical. Look at the given things. Two cells of EMF 1.5 volt and 2 volt and internal resistance 2 ohm and 1 ohm respectively have their negative terminals joined by a wire of 6 ohm and positive terminal by another wire of 4 ohm. A third wire of 8 ohm connects the midpoints of these two wires. Find the current through and potential difference at the ends of third wire. Circuit diagram is not given here. We shall draw with the help of given data. See here, a cell is given. Cell means a cell contains both EMF as well as internal resistance, and that internal resistance value is going to be very, very small. Okay. So first 1.5 volt. So this is 1.5 volt. And this is internal resistance. Together we call it as cell. Okay. So this is 1.5 volt and this resistance, internal resistance is 2 ohm. Okay. And another EMF, one more EMF is given. I mean cell is given, and this is 2 volt and resistance is 1 ohm. Okay, this is positive terminal, negative terminal, positive terminal, negative terminal. Okay, respectively, have their negative terminals joined by a wire of 6 ohm. These two negative terminals are joined by a wire which is having a resistance of how much? It is 6 ohm. Okay, and positive terminals by another wire of 4 ohm. Once again, this wire, positive terminals, but this is also positive terminal, this is also positive terminal. Both the positive terminals are connected with a wire having resistance how much? 4 ohm. This is 4 ohm. And a third wire of 8 ohm connects the midpoints of these two wires. Okay, it means a third wire connects this wire and this wire, midpoint of these two, like this. And its value is how much? It is 8 ohm. It is 8 ohm. Okay, and we can see, since this third wire is connected to the midpoint, we can treat this as 2 ohm and this as 2 ohm and this as 3 ohm and 3 ohm. Okay, so first we shall name it as A, B, C, D, E, F. Okay, so we shall begin our solution with the help of this circuit diagram. First, applying KVL, Kirchhoff's voltage law, to the loop A, B, C, D, A. To loop A, B, C, D, A. Okay, so we shall begin from this. Before that, we shall name the current. See, this is positive terminal, therefore this current, say it is I1. Okay, so I1 current comes at this point, and see, since it is positive terminal, say it is I2 current. I2 current is also entering at D, I1 current is also entering at D, therefore the amount of current at this point is I1 plus I2. Okay, D is a junction, C is a junction. Between the junction, current has to remain constant, therefore this current is I1 and this current is going to be I2. Okay, see, from D to C the amount of current is I1 plus I2, and in this point D, E, F, C, this point the current is how much? I2, because D is junction and C is junction. Okay, and between the junction current has to remain constant. So we shall begin our solution. So we shall start from this point. Current clockwise we shall apply. Okay, current is I1 and resistance is 2. Negative terminal, current direction is in this way and we are moving this way, therefore we shall take it as negative. So it is minus 2 I1. Positive terminal comes first, positive terminal, therefore it is positive 1.5. And I1 current is coming, 3 ohm resistor is there, therefore it is minus 3 I1. You reach D, C to this way. Okay, see here, current direction is this way and you are moving this way, therefore it is minus 8 I1 plus I2, and you reach D, and D, from D you are supposed to travel this way, current is this way, I1, current is opposite to your travel, therefore it is 2 ohm multiplied with resistance, current minus 2 I1 is equal to 0. So minus 2 I1 plus 1.5 minus 3 I1 minus 8 I1 minus 8 I2 minus 2 I1 is equal to 0. 2 I1, 3 I1, 5 I1, 8 I1. It is 13 I1, 13, 14, 15. Minus 15 I1 minus 8 I2 plus 1.5 is equal to 0. Or 15 I1 plus 8 I2 is equal to 1.5. Let us call it as equation 1. Similarly, we shall take one more loop, applying KVL to loop, this loop D, C, F, E, D. D, C, F, E, D. D, C, F, E, D. F, E, D. So we shall start from this point. I1 plus I2 into 8. So I1 plus I2 into 8. Once again you are moving this way clockwise, okay, and the current direction is also in your same direction, okay. And see, I2 is there, 3 ohm resistor is there, therefore it is plus 3 I2, and negative terminal comes first, therefore it is minus 2, and 1 ohm resistor I2 current, that is plus I2, and here 2 ohm resistance multiplied with current I2, so it is 2 I2, because the current direction and your direction both are same, is equal to 0. So 8 I1 plus 8 I2 plus 3 I2 minus 2 plus I2 plus 2 I2 is equal to 0. 8 I1, only 8 I1 is there, therefore it is 8 I1. 8 I2, 3 I2 is 11, 11 plus 1 I2, 12, 12, 13, 14, plus 14 I2 is equal to 2, or 4 I1 plus 7 I2 is equal to 1. Let us call it as equation 2. Since only 2 unknown quantities are there, 2 equations are enough. This is first equation and this is our second equation, okay. But look at these 2 equations. I1, I2 is there, I1, I2 is there, and here 8 is there, here 7 is there. We cannot subtract or add easily, so that one among these 2 get cancels, okay. Therefore what we are supposed to do is, this one equation is multiplied with 7, so that 8 7s are 56 is going to be there, and 7 is multiplied with 8, 8 7s are 56, 56 56 get cancels, okay. Therefore equation 1 is multiplied with 7 and subtracted with equation 2, which is to be multiplied with 8, okay. So I will do it here. Fifteen sevens are 35. 15 into 7, 105 I1 plus 56 I2 is equal to 10.5, and 4 8s are 32 I1, and 7 is there, 56 I2 is equal to 8. Since we are subtracting, therefore it is going to be minus, and it is also going to be minus, okay. See, 105 32, it is going to be 74, 2 is 3, 7, 73 I1, it gets cancels, and 10 it is 2.5. Therefore I1 is equal to 2.5 divided by 73, or I1 is equal to 2.5, we can write it as 5, and it can be written as 146. We have multiplied with 2 and divided by 2, so that it is going to be 5 divided by 146. Now I1 value is 5 divided by 146, and this I1 is substituted in putting I1 in equation. Which equation is easy here? See, equation 2 is easy, therefore we shall take it as 2. 4 I1 is 5 divided by 146 plus 7 I2 is equal to 1. So it is 20 divided by 146 plus 7 I2 is equal to 1, or 7 I1 is equal to 1 minus 20 divided by 146, or I1 is equal to 126 divided by 146 into 7. So 7 1s are 7 18s are. So it is I1 is equal to 18 divided by 146, or 9 2 9s are 2 73s are. Therefore I1 is equal to how much? 9 divided by 73 ampere. Now we know the current I1 as well as, this is going to be I2, Now we know the current I1 as well as I2. Okay. With the help of these two, I1 and I2, we are supposed to find out the current. Okay. See, find the current through and potential difference through the ends of the third wire. Third wire means this wire. Okay, D and C. Between D and C, the amount of current flowing is how much? I1 plus I2. It means D is a junction, C is a junction. From D to C, the amount of current is I1 plus I2. Okay. Therefore, the total current is flowing. I will erase this. Current through third wire or between what and what? Between D and C. Okay. As from the diagram itself, we can observe the amount of current is I1 plus I2 is equal to, I1 is how much? 5 divided by 46, 146, plus I2 is how much? I2 current is 9 divided by 73. Okay. So it is 5 into 73 plus 9 into 146 divided by 146 into 73. Okay. So it is 365 plus, and it is going to be 13664. So 1364 divided by 146 into 73, and it is 9271 divided by 146 into 73. So it is 73 ones are and 23 divided by 146. So it is I1 plus I2 ampere. This amount of current is flowing through this one, C to D. Okay. And we are supposed to find out the potential difference also. See here, potential difference between D and C. Potential difference between D and C. That is V is equal to I into R. I is how much? 23 divided by 146 into R. It is 8 ohm. So 2 4s are 2, 73s are. So V is equal to 23 into 4 divided by 73. 82 divided by 73. Approximately it comes to be 1.26 volt. Therefore, the potential difference between D and C or 8 ohm resistor, it is 1.26 volt, and the current across this 8 ohm resistor is how much? 23 divided by 146. Okay.